In section 5.4, we're going to be learning some special shortcuts for factoring. These aren't really in any sense necessary. The type of factoring you learned in 5.1 and 5.2 and 5.3, that could be used to factor everything that you're ever going to learn, but these shortcuts will definitely save you some time in some cases. These shortcuts are based on things you learned when you were learning to multiply polynomials. So here are a couple of multiplication shortcuts you learned back in the previous chapter. They have to do with when you multiply a binomial times itself. A plus b times itself, so a plus b times a plus b, or could have a minus sign, so it could be a minus b times a minus b. If you're multiplying something by itself, you actually say squared, so you'd say a plus b squared or a minus b squared. And again, the shortcut here isn't necessary. You could have done a plus b times a plus b using FOIL, or you can use this shortcut to get it multiplied out more quickly. What we're learning, though, is not multiplication. We're learning the reverse. We're learning factoring. So we're going to use these shortcuts backwards to factor things that look like the right-hand side into things that look like the left-hand side, that direction. So here's an example. Y squared plus 14y plus 49. So one of the first things you have to do is compare this and this to see if they're the same thing, see if they've got the same pattern. So here you'll see a squared has y squared there instead, so apparently a is the same as y. And where the original one said b squared, this one says 49, so b is apparently 7. Once you figure out that a is y and that b is 7, then your answer will be a plus b squared for these particular letters and numbers, y plus 7 squared. So that's a little quicker, a little faster than if you're just factoring using the FOIL factoring from 5.2 and 5.3. But let's take a look at a more complicated example. There is a downside to this. It's not as much of a great shortcut as it might appear at first. Here's another example. Slightly larger numbers, slightly more complicated situation. If you try to follow the same pattern, you would say 9k squared is in the place of a squared, so it looks like a is 3k. And where we normally have a b squared, we've got 16, so it looks like b is 4. So you would try to break this up the same way we did the one a second ago, a plus b, and you'd say 3k plus 4 squared, but when you check it, it doesn't work. When you check it, and remember, you should always check all your factoring problems, and you take 3k plus 4 and square it out, you get 9k squared, but you get plus 24k, not minus 24k. So the problem here is that because of this minus sign, this part here where we said b is 4, well, it's actually b equals negative 4. That negative 4 times negative 4 also gives you 16, which means that should be a minus sign, and now it'll check. So already it's slightly more complicated than it might have looked at first. You can't just look at the first term and the last term, figure out what a is, figure out what b is, and you're done. You've also got to pay attention to the middle term. And when I say pay attention to the middle term, sometimes you've really got to pay attention to the middle term. Look at these two problems here. The one on the left and the one on the right have the same beginning, the same end. If you look at here, you'd say, oh, it looks like a is 3x. It looks like b is 4. And you'd say the same thing for this one. It looks like a is 3x. It looks like b is 4. And there's no minus signs anywhere, so you don't have to worry about, oops, I got to put a minus sign in. But they have different terms in the middle. One of them has 30x, one of them has 24x. They can't both be 3x plus 4 squared. Only one of these actually factors that way. This one over here. The one on the left that middle term is not 2ab. What do you mean 2ab? Remember back at the top, this shortcut here requires the middle to be 2ab. It's not just a squared at the beginning, b squared at the end. The middle has to be 2ab. If we go back and look at this, 2 times 3x times 4, that's 24x, not 30x. 30x is not 2ab. And what that means is the shortcut does not apply to that problem. Now, that doesn't mean it doesn't factor. It just means it doesn't factor the easy way. The way it factors, well, you'd have to use something like from section 5.3. You'd end up with 3x plus 8 times 3x plus 4, or sorry, plus 2. So it does factor, but it doesn't factor using the shortcut. You have to factor it the other way, the more basic way. So if you're learning section 5.4 and you've learned this supposed shortcut and you discover that it doesn't really seem to always apply and it's kind of a pain, I don't blame you if you're a little skeptical. If you're looking at it and wondering, why should I even bother learning this? I'll just factor out these problems using 5.3's methods instead of learning these shortcuts. Well, it turns out that there is one shortcut that is useful. It's related to one more thing you learned back in multiplication. This pattern here, where you have a plus b not times itself, and a minus b not times itself, but you have one of each, a plus b times a minus b, that, if you remember, multiplied out in a very sort of surprisingly simple way, a squared minus b squared. When you first learned this, this was called the difference of squares. And this is a shortcut that will be easy to use because there's no middle term that you have to worry about whether it matches or not. You've just got the first term and the last term that you have to work with. If a squared is 49x squared, then that means a is 7x. If b squared is 81, then that means b is 9. So this thing is going to factor. Remember, we're factoring. We're going this direction. This thing is going to factor into 7x plus 9 times 7x minus 9. That's a plus b times a minus b. You could do the a minus b first and the a plus b second. When you multiply two things together, the order is totally up to you. Doesn't really matter. There is only one thing that you should be a little cautious about with this difference of squares shortcut, and it's easy to catch, so you probably won't have any difficulty remembering it. And once you remember that, you'll be very successful with it. The thing to be careful about is this sign in the middle has to be a minus sign. And if it's not, like in this case where it's a plus sign, then that means this will not factor into a difference of squares. It's a sum of squares. And a sum of squares, the shortcut doesn't work on it. So if you were thinking that maybe this factors into, well, let's see, 36 would break up as 6 and 64 would be 8. Well, let me suggest you check that. Take 6x plus 8 or 6y plus 8 and 6y minus 8, multiply it out, you won't get 36y squared plus 64. You'll get a minus 64. It won't check. That's, again, not to say that it doesn't factor at all. The only thing that factors out of this, in this case, is a 4. There's a common factor. And you might have been working on section 5.2 and 5.3 for so long you forgot about section 5.1. Don't forget about a common factor. The common factor should always be the first thing you look for, because it's easy. And if you overlook something easy like that, you should be embarrassed. So always look for a common factor first, because that will be a simple, quick starting point for any problem. One last example here. And this is a fun one. This is one that's going to kind of expand your understanding of factoring a little bit. Here, when you look at this, it looks like your first term is 4a squared squared. And your second term, the 81, that looks like it's 9 squared. So if you factor this using our difference of squares shortcut, you'd get 4a squared plus 9 and 4a squared minus 9. But that's not the end of the story, and this is something students often get lazy about. Once you've done one type of factoring, always look for another type of factoring. One step may not be the end of the story. In this case, that second one there, 4a squared minus 9, that itself is a difference of squares, and it can be factored further. So what you should be doing here is taking that one, thinking of it as 2a parentheses squared and 3 parentheses squared, and breaking that up as 2a plus 3 and 2a minus 3. So 16a to the fourth minus 81 factors into 4a squared plus 9 times 2a plus 3 times 2a minus 3. We are going to learn one more section on shortcuts in section 5.5, and then when we reach 5.6, we're going to do an overall strategy.